Good morning, everyone. Thank you for joining this call. Good morning, good afternoon, and good evening for everyone who just joined. My name is Ahmed. I am part of the SANS Cloud curriculum, and I teach SEC 540. I'm going to give you a little bit about myself, not too much. I work primarily for Lacework, now Fortinet. It's a cloud security solution, and I am based in San Francisco. It's a very nice day out there. Feel free to connect. I am interested in cloud security. That's most of what I do. But then also over the past couple of years or so, I became really interested in GenAI and what does that mean for us in terms of security. I would be posting a lot of things. Please feel free to connect and let's dive into this. So every year, SANS does the Cloud Security Exchange. And for the 2024 version, we have multiple different discussions, different topics. And one of them, obviously, was Chapter 5, which is the AI Security Challenge, Hype and Opportunities. That portion was written by Brandon Evans and myself. And this talk is basically based on the research that we have done as part of that. This is the link right there. Please feel free to go and check it out. It has a lot of interesting topics. Now, with that, let's begin our discussion about generative AI. This is going to be a casual session, right? We're going to talk about some of the basics, but then we're going to build up and try to understand what does GenAI applications look like, and what does that mean in terms of security, risks, challenges, and a little bit about some use cases that we might take advantage of as part of security practice. So to begin with, everyone knows what GenAI is at this point, right? We have seen ChatGPT. You basically go and talk to it, and it will generate content, right? It will generate text. It will respond to whatever prompts you have. It can generate things like images, music, videos, and so on and so forth. Now, the foundation of this technology is the large language models, right? We're not here to talk about ChatGPT per se, but we're going to discuss LLMs. What are they? If you really want to break down something like the chat application from OpenAI, ChatGPT, right? It comes down to two major components. The first component is your interface. That would be the chat interface that you have. And then behind the scenes or in the background, there is the GenAI component, which is the subject of our topic today. The GenAI component primarily consists of the LLMs, which is the actual model that will generate whatever that content is. Now, we have many models, right? OpenAI is not the only one. They are definitely the most popular and one of the most powerful as well. But we have other organizations who are actively building up different types of models as well. And we will talk about some of them during the next hour or so. So Meta, formerly Facebook, have created Llama. And I think the recent version is Llama 3.2 now. And Llama is an open source model that you can use, and we would see examples of that. But then also the cloud providers are creating their own. So for example, AWS have their own Titan, and there are many as well. Anthropic Cloud is an important one to look at as well. Now, let's dive a little bit deeper into this and see what does that mean if we want to have an LLM inside the application. The core idea is that in the future, in the very near future, every application out there could have some sort of an AI, GenAI, LLM component built into it. Imagine if you are to build some sort of an application right now, would it be fair to say that almost every application out there will probably have some sort of a database component, right? And then that's how we think about the GenAI or the LLM component. It's just a component that lives inside the application. What that means is that we would have to think how does that work to begin with, right? What does that mean in terms from a technical perspective? And what does that mean in terms of security? What are the risks that are involved? But before we get to that, let's cover the first part. What does that mean and how does that work? If you look at the screenshot on the right-hand side, you'll see, I think you can see my cursor right here. So this comes from the documentation of OpenAI, and you can see that there is some sort of an API connection to their models that could come from inside any application out there. So that's the first thing, right? So we have an application, and then from that application, there will be some sort of component that lives outside that application. And you can see examples in here. You can see that line number 5, we're choosing the model. So there are different models, and we get to choose which one. And then we're sending different types of messages as well. It's also important to note that authentication happens usually via API keys. So there is a key that we have here, and we will supply that along with this API request. What does that look like? Well, it looked like something like this. So this is a testing application. So that would be screen number 2 right here. I hope you can read it. It's a little bit small, but I can help you out pointing the important parts. So this small application, it's written in Python, as you can see. And what we are doing here is that we're sending some input. And the input says, show me instances in USEast2, display instance ID, instance name, AMI in the table. This is just a proof of concept, right? To kind of see what can we do with these LLMs aside from chatting. And what's in green is the response from the LLM itself. Now, important things to notice here. This is not a typical behavior. If you go to ChatGPT right now and type in the same sentence, show me instances, etc., 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 it's not going to give you such a clean command. If you notice, the green thing is an actual AWS command that executes and gives you that information. What this application is doing is that it tuned, well, I shouldn't say tuned, it altered the way the model works so that it only gives us a command, an AWS command, that will actually give us what the information we need. And then the rest of the application, which is the traditional type, the traditional part, is actually executing that command and then giving us the results back. I'm going to pause here. Does this seem like, hey, we have commands being generated by a model, and then these commands are being executed? So from a security perspective, that should trigger certain questions in our heads. But nevertheless, this is to show what we can do with that. Now, there are other considerations as well. So the first thing is, these LLMs require high processing capabilities. So we need a number of GPUs, right? Some chips that are expensive, which makes it challenging for us to build applications because, you know, there is a barrier. Now, this is why most of the applications we see today are cloud-based, right? Meaning that the models themselves are hosted somewhere in the cloud. So that could be your OpenAI, right? OpenAI has their own infrastructure built on Azure, and they will take care of scaling. You don't have to worry about that. They will give you all the advantages that you get from using any cloud service out there. But there is more than that, right? There are services out there, such as Hugging Face, which help people to build models, share these models, and then also host these models there. And there are many organizations who are doing this as a business model. Hey, we offer you a service for hosting your models within our infrastructure. The typical cloud service providers that we have also do that as well. So you can host these LLM models inside AWS, Azure, GCP, what have you. So this is also interesting, right? Because now authentication might be different. So if you're working with OpenAI directly, they just issue an OpenAI key. You have to manage this key, and then that key is used to communicate between OpenAI itself. When you're using a different provider, authentication might be different. It's also important to note that we have SDK support for all of these different models out there, and that would allow your application to communicate with that. Now, the obvious thing is that we have privacy concerns, right? I'm going to go back one slide. So check this out. There are certain data that we are sharing with these models. So for example, if you look at the second screen, it says this command in map, right? It generated this. So there are IP addresses that could be shared as well. Now, depending on your use cases, these information could be super critical and important, and it could be not so critical. If you have an application that basically helps the users navigate some sort of public information, so maybe documentation, right, or documentation for how to do things. So if you go and say, hey, I would like to create an application that will help me to write Terraform, well, the documentation of Terraform is public. So that's really not a big deal, right? But if you are an organization and you need to create some sort of a chat application that helps your user looking into internal documents and processes, maybe, then that becomes a different story. So with that, we do have options. And the options is we can also run these models locally. Remember how we said OpenAI is not the only one, right? So this is an example of a tool called Ollama. Ollama is an open source tool. You can just go to their website, one click, and you can download this thing on your laptop, and you can run models on your laptop. It works in a server client base, So the green screenshot in here, that's the server component. The white one is the client component. Let's look at the client first. Check this out. I'm saying, oh, Llama, run this specific model, Llama 3.1. And when you run this command, you are greeted with an interface, and you can just chat to it, as basic as that. Now, what happens on the back end is that there are API requests that are going, and you can tell from the IP address that this is local. There are requests that are being sent from Ollama client to the Ollama server. Both are running on the same laptop. This laptop, by the way, is not anything fancy, right? This is a model that runs fairly fast, but the hardware component is not anything fancy. As a matter of fact, if you look at the first line right here, it tells you this is a GPU of Apple M1. That's a 4-year-old laptop, right? And that's it. And you can actually chat to it. Does that seem like it solves the privacy issue? Now, everything being generated is contained within this laptop. Now, obviously, this is not very efficient for production scale, but you can easily imagine how you can get your own server locally and run some sort of a big model on that. All right, sounds good. So it seems like we do have options, and our application could have the AI component either in the cloud, somewhere hosted, or locally. All right, we will get back to this discussion. But it's also important to note that these models, whether they are big models or smaller models, their knowledge is not infinite. They have a limitation with their knowledge. But there are ways to extend this knowledge, and that comes through the agents. So the agents are basically the part of the code that interfaces, that help the model interface with the rest of the world. So take an example. Right now, if you need to find some certain information that is very recent, if you open ChatGPT and you say, hey, what happened yesterday? Can you summarize the news that happened yesterday? It can actually go and search the internet and gets you the result. That happens through the agent. So the model will say, oh, I don't have that information, but I have ways to get that information for you. And searching the internet is not the only thing. You can actually have different types of agents that do different types of things. So for example, you can have some sort of an agent that can interface with any other API out there. So as an example, imagine an application that helps you booking tickets. So you can say, hey, can you show me the tickets that are going from this city to this city? And then the application, the model, needs to be able to create some sort of an API request, send it to, let's say, Expedia, and then it will get you the results. And then the next step would be, hey, can you book this specific flight for me? And then the model will need to go back and actually create API commands, API requests that will help you to book that flight. So this is very interesting now. We have agents, we have LLMs that will basically interact externally. Again, something to think about from a security perspective. Now, this is not the only things that we can do. Another good example is that when you need to extend the knowledge, but you need to limit that knowledge with some sort of a data that is vetted, right? I don't want this model to go and search the internet and get me random things that might not be accurate, or it might, right? So an alternative way to say, hey, use this specific set of data to base your answers on. And these could be your internal documentations as an example, right? So I can get all that internal documentation, feed it into some sort of a database, and then configure one of my agents to go and query this database. Typically, this is not your average database. What this is a vector database. And the vector database is slightly different. Well, it's drastically different. The way it works is that it stores chunks of data in a vectorized manner, meaning that it has values and it's broken into different paragraphs, if you will. And then we are going to use another type of models called the embedding models. What the embedding models are going to do is that they're going to go and find the most relevant pieces of information or paragraphs to my question. So if I ask, hey, what is the process of applying for PTO in my organization? Then that embedding model is going to go into this vector database, fetch you the actual documents that talk about that, and it will feed all of this into your original LLM. This process is called RAG, Retrieval-Augmented Generation. Now what you're saying, hey, LLM, this is the 5-10 documents that are relevant to the question. Can you answer the question now? So you're limiting the hallucination issue in that. Let's take a look at how does that fit in terms of a design. This is how it could look like. Let's examine this. So we have user requests coming through the interface, and this interface is going to have the LLM components, the embedding model components. So these are two different things. Both of them could be hosted locally or in the cloud. And then you have the vector database component, which also can be hosted locally or somewhere in the cloud. And then you have other agents that are communicating with different things, search engines. In this example, CSP interface. So for example, saying something like, can you get me this data from this bucket? Maybe someone uploaded a resume and you need your LLM to go through this resume, helping you to make decisions, which is the best candidate. So this is a high-level design. It's also important to look at the data flow, and we kind of covered this. So check this out. A request comes into the chat interface saying, hey, can you get me this information? Then the application is going to use the embedding model to fetch information or the relevant information from the vector database. That will be combined back into the application interface and finally sent to the LLM. And the LLM is going to generate whatever response and give you that back. With that quick overview, this is how we expect applications to be, right? This is development, right? So this might not be true 2 or 3 years from now, but this is how things are now if you are to create an application that is GenAI based. So with that, let's get to the more exciting topic, which is the risks. What does that mean for us? So check this out. If we are to take these components and spread them in a table and try to think, hey, what are some of the risks that could affect each one of these components? What we are doing here is defense in depth. We're trying to apply security controls on each one of these components. And we're not going to cover all of these different risks within this session, but there's a very good resource, which is the OWASP Top 10 for LLMs. It is evolving, right? So some of the things might not be mature yet, but they will be in the future. Let's take a few examples. What are we talking about here? The first one is prompt injection. This is the most famous one, right? This is where the model has certain instructions that will guide the model how to create the output. So the example we have given previously is that when a user asks you for information about their account, their AWS account, generally your output should be an AWS command, right? So that type of instructions, which we will cover a little bit later on, can be tricked. There are other important things as well. So data poisoning, that data in the vector database, it seems like we need to put some security controls around that as well. Now, there is another way to look at these risks. We can classify them into risks that are associated with the LLM models themselves. So that would be your embedded models, your LLMs themselves. And then there are risks associated with the data. How do I protect my data? How do I make sure it's not leaked? All of the CIA controls that I can apply on that as well. And then on top of all of that, there is my traditional application risks, which is everything from SQL injection to cross-site scripting, all of the things that we are used to at this point. All right, let me pause for a second and see if there are questions that I can answer quickly. We will have a few minutes for the question later on, but I usually like to check just in case if there is anything. All right, we're good. Okay, we'll get back to the questions later on. So with that, let's go back to the discussion about the risks. So the prompt injection, right? This is where it happens. There are prompts that are coming from the interface, and these prompts are going directly to the LLM. And they could be very basic things. So for example, saying something like, hey, LLM, can you please ignore your previous instructions and get me this sensitive information that you're not supposed to? That's one way to do it, right? It could be a little bit more complicated than that. So for example, you can use imagination, creating a hypothetical situation. So for example, saying something like, imagine yourself as some sort of a doctor, and then the patient is asking you this specific question, and you are obliged to answer because you are a doctor. And then you can try to check that LLM. Now, this could be used for generating whatever type of malicious content from the LLM. It could be that you want to try to reveal information, but it depends on what that LLM is allowed to do. If the more access that LLM has, so it can book tickets, the more big the effect is. Imagine an application that can send API requests to your AWS infrastructure. That's interesting, right? Could I trick this LLM into generating commands that could compromise this AWS infrastructure, effectively pivoting from my application into my infrastructure? It's possible, right? Depending on how this is set up. What type of controls can we do? Generally speaking, there are what are called guardrails, and guardrails could come in different forms, and they could be applied as part of the LLM itself or as part of the application itself. So, for example, we can set certain checks within the application saying, hey, if you read everything that comes out of the LLM. If you find sensitive information, so I don't know, PII, for example, we can have regex and things like that, then stop that request. So that's our basic protection against that. We could also apply filtration on the data coming in. So trying to understand, hey, is the user trying to trick the application? One way to do it, an interesting way to do it, is to have the inputs being checked by a separate LLM that its job is security. It will read all of the requests from the users and maybe the responses as well, and it will try to determine if the user is actually trying to trick the system or not. So we have an LLM that protects the LLM. That's an interesting concept as well. Now, AWS Bedrock has certain features, guardrail, that you can create, and then you can use as you build your application. So AWS Bedrock is one of the frameworks, one of the services out there that will help you build applications using the LLMs. It will host LLMs for you, but one of the features is also to have the guardrails that will help you to apply security controls against this LLM. All right, another interesting topic is that we did mention a couple of times that we can create models and we can change the behavior of these models. We can create slightly variant versions, and then we can fine-tune the models as well. The bottom line is these models could be shared, right? I can create my own model and then share it. Other people can use it. Does that mean supply chain attacks, right? As a matter of fact, we should be really, really paying attention here. There are many malicious models out there. There are also poisoned models. In the near future, whenever you have an application that is GenAI based, you will probably have some sort of a pipeline that builds models as well. The same way you build Docker containers and images, right? You build Docker container images, you apply security to them. We will see that we will be building models or fine-tuning models, and we need to apply some sort of a check for them. We are already seeing this in the news, right? There are already hundreds of malicious models out there. Hugging Face is an open platform. Anyone can upload things, and anyone can use these models from everywhere. And it seems like that's a recurring story within the cybersecurity world, right? Every time we have a new technology, we don't know much about that technology yet, but the business needs to use it for competitive advantages and business advantages, obviously. So we would rush into using them, and then we would end up with headlines saying this many public S3 buckets caused some sort of a compromise in there. It's the same story here. And it will take us time to kind of adapt and learn what are the securities and how to fix them. And this is part of what we are doing. And I feel like we are doing this much faster than with other technologies. Now, this had led many people to say, hey, if we are creating SBOM, software bill of materials, for other artifacts that we are building within our pipelines, so an example would be the Docker container images as an example, why don't we create AI bombs? So every AI model that you create, I need to have some sort of a bill of materials. I need to know what's inside this model. Let's dig a little bit deeper into how does that work. This is the example of Olama. And as we mentioned before, Olama is this basic software that you can download on any laptop or desktop, and you can use it to run models. What that will mean is that it will run the model, it will give you an interface to communicate with, and it will manage all of the API things that are happening with that. But you can also use it to build your own models. Check out this example. So this command right here, Olama create, then Ahmed, Hackerbot, SPL, -f model file. If you have worked with Docker images, you would notice that this is very, very similar to how we create Docker images. You also have a push command, which means that you can take this new model that you created and push it somewhere in the cloud, maybe, right? You can push it in this specific area to the Olama library. That's an open repo. That's the equivalent of Docker Hub. Then you can also say, run this specific model. If you remember the previous screenshot, it said, run OLAMA 3.1. In this case, I'm saying run this specific SPL, Hackerbot SPL model, which, as you would expect, it would do different things than what the original model is. Check this out. I can also say OLAMA list, and it will show me all of the models that currently live on my system. And you can see the OLAMA 3.1, and you can also see my Hackerbot SPL. And I will tell you exactly what this does in a minute. But the one thing that I wanted to show you is the size. This is 4.7 gigabytes. This is the smallest Llama 3.1 out there. It's the 8 billion parameters, because I couldn't run more than that on my personal laptop. But you can notice that these two are not really fundamentally different. The difference is basically this line right here, and I'll explain what this in a moment. This is an example of a model file, and the model file will say something like, this is your base model, so from this specific model, in this case, Llama 3 or 3.1, and then after that, these are the changes I want you to make on this base model. One of the changes could be the system parameter right here. The system parameter is basically your instructions. So when we're creating a model this way, we're not really creating an entirely new model. We're just changing the instructions that this model has. And the instructions could be something simple, such as you are Mario from Super Mario Brothers, etc., etc. This comes from the documentation of OLAMA. But this is an example of the actual instructions that are part of the Hackerbot SPL. And you can take your time to read through it. It's not a lot. You can see it's probably, 30 lines or so, something like that, right? What this says is that, look at this. You are part of a program that searches Splunk. And your job is to create, so line number 311, create Splunk queries based on the user input, which means that your output should not be just random output trying to explain things. It should be clear SPL, because we're going to take this SPL and execute it against an actual Splunk instance. So that could be an agent that we have, right? What we are doing here is that we're not training per se, but changing the behavior of the model so that it suits our use cases. And you can see that we can add instructions, use this, use that. Whenever the model fails, you would add an instruction, and then we would add few examples in here. You can see that we have, 10 examples, 15 examples, right? This is a main difference between making changes through system and making fine-tuning. With fine-tuning, you would have to provide a list, maybe thousands, tens, or hundreds of thousands of examples, and you would retrain that base model to use your newer examples. That would work, but obviously the downside for that is that you need to have vetted examples, thousands, maybe hundreds of thousands of them. This is much easier. So what you are doing essentially is taking this, combining it into that model, and then pushing that model up into the repo that you have. Once you have that, we will see examples of how this can be used. All right, so the other risk we're going to quickly talk about is the data risk itself. So check this out, going back to our original high-level design graph. So check this out. The data is basically being moved between the interface and whatever data sources you have. So that could be your search engine, whatever data the agent is using. It also could be your CSP interface, and it could be your knowledge, your vector database. Because of the complexity of this, we expect that many implementations might not pay attention here, because there is authentication components between this database and the embedding models. Now remember, we have to create this database, we have to put data in that database, so we have to have some sort of a pipeline or a process that is secure for us to add data to that database to maintain the integrity. But then we also need to make sure that nobody else can actually access that database except the embedding models that have the proper keys and so on and so forth. And speaking of keys, we follow the same security recommendation for anything else when it comes to keys, right? We store them in a secure location, we use them in a secure manner, no clear text, etc., etc. So the other thing that we need to talk about when it comes to data is the concept of sharing this data. Now, remember when we said, if you're using a cloud version, so OpenAI, for example, that means you're going to send this data, which could be sensitive, to OpenAI themselves. Well, what happens when you have your workload running in some sort of a cloud, so Azure or AWS, and then also your model runs into inside that platform as well. Does that make a difference? I mean, obviously it depends on your data, but the thing is your data is already shared with AWS or Azure or whatever cloud provider you have. So they have a significant advantage, or there is a significant advantage for running your LLMs inside one of these cloud providers as well. Now, these cloud providers, they realize that, so they're creating tools that will help us to navigate. This is a screenshot from AWS Bedrock, and you can see that it has a bunch of different options. Guardrails are here, right? You can create those, but you can also create the playground. And the playground, if anyone played with the OpenAI playground, this is very, very similar, but it gives you the ability to compare between different models. So comparison is interesting. So look at this. This is Llama 3, 8 billion parameters, and then this is 70. So it's the same model, but a bigger version of it. And I don't know if you can read, but basically you can ask the same question, you can compare the results. Obviously, the 70 billion version is much better in understanding, comprehending, quote unquote, understanding your question, right? Fun fact, I tried the bigger one, which is the 405 billion, and it didn't give me the same results as this one. The 70 billion was much better, actually. Just a side note on that. Now, with that, the final risk that we are going to talk about is the application and infrastructure itself. So obviously, this LLM Gen application doesn't live in a vacuum. It lives within certain infrastructure that could be your local on-prem infrastructure, or it could be your cloud infrastructure. And if it is either, then we have to assess, hey, can anyone actually pivot from these LLMs into our actual infrastructure itself, especially that these applications are going to need to communicate with other components of the infrastructure that we have. The last thing I want to share with you today is an example that could kind of show us in the security community what this could mean in terms of use cases for us. This is the Hackerbot application that we are testing with, and check this out. So this is running based on OLAM, right? And in specific, Llama 3.18 billion model. This is the smallest model, and it's running locally. So there is no data sharing whatsoever. So check this out. What it is doing is saying, hey, what users logged into my AWS account? Oops. And then this is what was generated. So you can see it's a specific SPL query. And then the application is going to take that and execute it. You can see there are some SSL verification issues. It will execute this query onto a Splunk instance, and it will display the results. So this part right here is not GenAI related. Now, once that is done, we will also take a next stage and take this data, the output that came from Splunk, we're going to share it again with the LLM, and then we're going to say, hey, can you analyze this for us? And this is the analysis right here. Think about the possibilities. This is a POC, right? So it's not as perfect as this screenshot shows, but it might become soon enough. What this means is that now I have had the LLM to do a lot of the work, including generating the SPL, but also pointing out things that I might not see if the output is too big. In this case, we have not much of a big output, bunch of different users that are basically, hey, how many times they connected, and then there's a small summary that the LLM did on this data, which is a task that the LLMs are very, very good at. Feel free to explore the code. You can reach out. This is the link right here. And with that, the final remarks that I have for you is that, hey, these GenAIs are not magical solutions. They come with tremendous advantages, but they also come with risks. And this technology is evolving, right? It's not set yet. So we don't really know exactly what's going to happen 5 years from now. But at this point, we're doing research and trying to stay ahead and understand how these applications are working, how do they evolve, what does that mean in terms of risks for us, so that we are ready whenever we decide to create or buy some sort of a GenAI application that we have. Keep an eye for classes on this topic. And with that, any questions? You can see that the GenAI is not perfect because this image was generated by a model, and you can see that it misspelled the word generative AI. It doesn't even know its name. With that, let me see if we have questions. So we have a question about it from Jeff. It sounds like a good way for employees to ask questions about company policy. Well, yes, but not just the policies, right? Any information. Like, think how many times you at your work try to find some information and you had to kind of hunt that information down, trying to talk to many people, trying to see, hey, who actually knows how this thing works. So it can be really, really helpful. But the more helpful it is, the more access it needs and the more risks it has. What are the LLMs that validate security? That's a very good question, Jose. So there are many LLMs that can do different tasks. But when I mentioned LLMs that validate security, I meant to say that you can find a model, any model, right? And then you can create instruction set for that model that will basically say something like, hey, your job is a security analyst. Can you read this user prompt and the response and try to determine if there is some sort of a trickery that's happening? So it doesn't have to be a specific model that validates security. You can create your own. The instructions will be different, right? So the model would look at this data in a different manner. And then you can also instruct that model to generate specific type of output, saying, hey, your output should be true or false, or yes or no. Was there trickery or not? And based on this, your actual application could make logical decisions, basically allowing this data to go or not. Does that make sense? So it's not a specific LLM. Let's see. So threat modeling scope should be defined as what can the components which organizations scope versus OpenAI. So the question is about the cloud responsibilities that we have such a scope yet. So I don't know if this is set yet, right? The responsibility model, but I think it's fair to say that we can reflect the responsibility models that we are used to in the cloud on the AI models as well. It's not as simple as that when it comes to data and training data and so on, right? If you want to go too deep, but you can limit what is their responsibility, what ours. If, for example, if you host, for example, if you talk about OpenAI, right, their responsibility is to secure their infrastructure. So as long as they're doing a good job doing that, right, then that basically takes off some of that responsibility. Our responsibility in that sense is to protect the OpenAI key that they generated for us. So we're not going to have it inside the code, maybe find it in a GitHub repo or something like that. I would say that the cloud providers are very mature when it comes to securing their part. And they gave us a lot of security tools that we can use as well at this point. So are LLMs more Python code? Well, the LLMs themselves, designing the LLMs, is not part of this discussion, right? It could be Python, it could be whatever that is. Our application could also be Python or any other application, right? It doesn't matter. It doesn't have to be. You can write bash scripts that communicate with LLM models. Let's see. We have a lot of interesting questions. I don't know if we can go through them. We still have a little bit of time, so let's see. Okay, so that's an interesting question as well. Do you have suggested resources to learn and stay up to date on GenAI security topics? Yes, sans. No, I'm kidding. But yes, a lot of there are so many resources out there. I would say the best way is to join lists that will give you updates. The challenge with this is that it changes often. We were doing research. We did research last year. This year, most of it outdated information. Not really outdated information, but for example, in the past few months, we had Llama version 3.1, which was a significant improvement over 3. And then a few weeks back, we had 3.2, right? So everything you see here was tested on 3.1. 3.2 is drastically smarter than that. So I would say you have to keep up. Let's see. So how do we, any recommendation URL textbook for learning AI from, oh, okay. So I would say to begin with, go through the documentation of OpenAI themselves, because the documentation, it doesn't cover what LLMs are. It kind of briefly does, but it doesn't go into the details. However, it gives you examples of how you can use code to do that. Now, same thing with the other tools that you have. So for example, vector database, right? I've been doing some testing with Weaviate, and Weaviate is one of the vector databases out there. PinePhone is another one. If you go through the documentation, you will find explanations on how to use them, and also explanation and also examples of how to use them as well. I would say that's the best way to learn, right? Just go through documentation, try to build your own application. And in a way, this is similar to anything you learn, right? You go through the documentation. There isn't a lot of complete training sets as of now, at least that I'm aware of. If anyone has any recommendation, please feel free to share. But I would go to the documentation, to the source at this point. So what approach could be used when testing injection? Is there a list of prompts to try? That's a good question, anonymous. So there is a difference between SQL injection, as an example, and the LLM or prompt injection. The SQL injection is SQL. It's kind of finite, right? It could be a lot. If you are to create a list, the list could be a very long list, but it's still finite, which makes it easier for us to create some sort of a list that would say, hey, as a web application firewall, if you see this, then that's probably an SQL injection, therefore stop this request. With LLMs, there are things that you can detect, but it's not as easy as that. That's why we said one of the best ways to do it is to have another LLM to read this natural language injection attempt that you have. But you can do a little bit more than that, right? Or other things than that. You can have specific keywords that you can check for. You can also have specific secrets. If your goal is to protect secrets, for example, you can hard code certain logic that basically says, if this secret is being passed, then drop it or mask it, right? We also do that with web application files. There are a bunch of other things that you can do as well, right? You can, for example, instruct the models themselves to not fall for these tricks. Now, that is a little bit tricky, but the one thing I would say is during testing this, the smarter, quote unquote, smarter models do much better job than earlier models. So for example, if you're using Llama 3 and you're trying SQL injection and you have instructions saying, do not respond with a specific secret, the moment you switch from Llama 3 to Llama 3.2, it understands your instructions much better. So my expectation is that as we move forward, it will be easier for us to detect these prompts. But as of now, it's not clear yet, but in the future, it will become easier. There are other options as well. Are there LLMs that are valid CTF? You know what? I think there is. I'll get back to you on that. Let's see. There's a specific questions about SIC 595 training. 595 talks about machine learning, right? So it talks about AI and how you build the application. I'm not sure if it goes into the applications themselves, but we will have other classes that will go into the AI gen security itself. So stay tuned about the classes. SIC 595 is a great course to understand how machine learning works and how you can apply it in the security world. It doesn't just talk about GenAI, it's a little bit bigger than that, right? You can build your own models, not necessarily generative models, but other types of models, and you can use them. That's what the class is about. The best way to restrict access of GenAI to limit data sources. I would say it's very similar to any other application, right? So for example, if you take the example of Weaviate, the vector database, the vector database itself has certain configuration that you can mess up, right? You can configure it in an insecure manner. You can allow anonymous access to this. Obviously, we're not going to do that. Then you can allow authentication using keys. That might be a good thing. But then you can also allow authentication using something like OIDC, right? Which makes it much more secure. So I would say just follow the best practices of whatever vector DB you have, configure it properly, and that should be good to go, right? Now, in terms of the other data sources, if your question was about other data sources, such as Google search, for example, you can filter these answers as they come back, right? So as they come back, meaning you can also have another LLM that checks for certain issues that's coming from an external source. An example of that is, let's say you have an AI model that reads your calendar and helps you, answer a question about that. And maybe it has write access to your calendar as well, saying something like, hey, can you create an event? Remind me of this and that. What that means is that someone could send you an invite, just an email, just a calendar invite, and that calendar invite will be consumed by your LLM, which means that maybe someone could do some sort of an injection that way. To address this issue, you basically want to do what you're saying. You want to limit sources, or at least apply some checks. In that case, you can also apply the same idea. You can have a model that checks for this data before they go into your actual LLM application. So there is a question, more like a suspicion, is the LLMs the best way to check the integrity of the LLMs themselves? Is there another way? I'm skeptic to rely on AI only. You're absolutely right to be skeptic to rely on AI only, because as we said, hallucination is a big thing, and we need to be able to do more than that. That's why defense in depth, right? So you don't only rely on AI. You apply actual checks. So for example, checking for sensitive keywords. And then you apply checks on the instructions themselves. You make sure your instructions are solid. They do not have rules. And then you try to use the best models out there. So every time there's a new model, you will need to keep up. All of this is not related to the actual check we're talking about. And then on top of all of that, you add that layer of AI to predict. So you're not only relying on a single factor, on a single protection mechanism, but you have 4, maybe 5 different mechanisms that you have. And then outside of all of that, you also apply security checks on the process of building and using these models to address other issues as well, such as supply chain and so on and so forth. Cloud formation. Okay, so there's a question. CFT, it seems I missed the question. Cloud formation template. So I think your question is, can we use LLMs to generate cloud formation templates? You absolutely can. And as a matter of fact, there are projects that do that. Check out this project, asecure.cloud. That's exactly what they do. They have a generative model that creates templates, not just cloud formation templates, but also Terraform and other things. And it does a lot of things. So it answers questions about your cloud environment via natural language, but it also generates cloud formation templates and Terraform code in a secure manner. So for example, you can say, hey, can you generate code that creates a secure bucket, for example, and then it will create that for you. There are many attempts to do that. I would say we are moving quickly in that sense, right? All of these models that generate code, it seems like they're doing a very good job, actually. You still have to obviously look at this code, whether that's a CloudFormation template or anything else. You want to audit it and verify it. But I would say it gives you a good base. I use this all the time, right? Can you create a bash script that does this and that? And then OpenAI, ChatGPT will create things for me. And I'm always surprised how good it is. But then I always have to tweak something. And I can ask it to tweak as well. So it's the same thing, right? CloudFormation template is actually easier than actual code. The one challenge I would say that I have seen with this solution is that because of the limitation of the size of the prompt that you have, the longer your code is, the more difficult for the model to create. So if you ask the model to create a small portion of the CloudFormation template, Terraform, or any function, it will do a very good job. So for example, you can say, create a bucket for me. That's really good. But if you have it to be more complicated than this, saying something like, can you create a VPC network with buckets and with EKS cluster and with this and that, and you have a paragraph explaining what you need, then the generative AIs, at this point, at least the models that we have, there's a higher chance that they will miss something. But they will give you a very good base that you can build on top. And I feel like that's the key, right? You don't trust the AI 100%. The challenge is the better they become, the more we're going to trust them naturally. So that's a different type of risk outside the scope of this, but it's something to think about. So when there's a question, when you mentioned we can check for specific keywords and reject, are you suggesting a blacklist approach? Is it possible to have domain LLM where each domain can define allowed safety? Yes, absolutely. That's exactly what I meant. As a matter of fact, that's a big part of what the Bedrock's Bedrock's guardrails are. You basically can have, obviously that's not the only thing, but you can have a blacklist saying if these words are mentioned, then block this attempt. Now, this is also tricky, right? Because it's a natural language. So not only you can use different words that mean the same thing, so in this case, blacklisting becomes more tricky, you can also use different languages. So imagine if you're blocking the word secret, right? But then someone says the same thing in a different language, such as Spanish. So therefore, part of the instructions, part of the recommendations for instructions, saying something like, only answer questions in this specific language. English as an example. So that's another idea, right? And you can think like how many hundreds or maybe thousands of languages we have. And the models are very good at interpreting these different languages, at least the major ones, at least every language I tested. So that's also something to keep in mind. Again, blacklisting by itself can work, but it's the most basic thing we do. We need to do a little bit more than that. All right, we have another question about SOC. How to monitor prompts which users submit critical data SOC analysis with POV of SOC analysis. So if I understood your question correctly, you want to log the prompts that the user are doing and then sending that into some sort of a SIM, and then the SOC people were going to analyze that. I mean, that's not as easy as it seems because there's privacy issues, right? These prompts could have sensitive information. The main reason why you want to move your LLM from the cloud into on-prem is because of privacy. If you're sending these logs into your SOC, then think about it as, hey, when you have a banking applications, do you send all of the different requests with the passwords, with the sensitive information into your SOC? Probably not, right? You still need to log this somewhere, but maybe not the SOC, unless there's a specific incident where you need to investigate. That would be at least my approach. What you could do, though, is that all of these controls that we are applying, the logging from these controls should go into the SOC, right? So whenever a model, whenever one of these controls say, hey, I detected something, then that should go to the SOC for further investigation. So an alert would look like, hey, our security model detected that this user tried some trickery on our application. So that would be something to investigate. And then in that case, you can ask for access to that specific prompt, and then you as a human could verify, hey, is this accurate or not? There's another interesting question about digital evidence. So the question is, how do we gather digital evidence proving to misuse GenAI models or poisons models? All right, so we do it the exact same way we do it with everything else, right? When you think about building applications in some sort of a pipeline, right? So you have a CI/CD pipeline, you're building your different portions of the application, and everything you build is logged. Every action you take is being logged. And there is chain of custody because you're creating these artifacts, and you can tell that this specific artifact, so a Docker container, for example, was built by this user, by this pipeline, this timestamp, and this is the component of it. You can do the exact same thing with LLMs. The important thing is we need to establish such pipeline that builds these models so that it can have a proper log, so that we can actually go back and look at this evidence when we need to, if we need to, right? And this is how we can protect against poisons or malicious LLMs, by establishing a very solid process. There will be more discussions on this. And actually, as a matter of fact, this specific topic is part of a class that we are working on about GenAI security. But you're absolutely right. That's a very good observation. So there's another question from Raphael. Do you believe the bigger models, 70 billion parameter, would run common laptops? So nobody can answer the future, what would happen in the future, right? But what I can say is that it seems like we are, at least that's my expectation, it seems like we are moving towards more processing powers, more processing chips happening on our servers and laptops as well, and phones and so on. Because everything you use now is going to have some GenAI component in the future, right? So think about your phone. It does have GenAI components already, right? It's running locally on your phone. And that might mean that we can have CPU and the GPU and another type of processing unit that is GenAI related. I can tell you more than this. More and more parts of the operating systems that we're using are going to rely on models, which means that it's quite possible that you can run way more than the 70 billion parameters models on your laptops in the near future. It will become a bigger and bigger component of our hardware that we use. Again, this is the future, so nobody knows, but at least that's my expectation. All right. So with that, I believe we answered all of the questions that we have. This is a very big topic and it's evolving. Stay tuned. We have more to come every few months or so. And thank you so much for attending. and hopefully we'll see you soon.